Good afternoon. I welcome you all to this series of webinars on Python learning. This is the third session of Python learning in the series of webinars. Let me start with this. So in today's session, last session, we have seen about the different types of data, what Python supports, different types of operators and all that. So in today's session, in continuation of that, in today's session, what we are going to do is we are going to learn about the different data structures. Any programming language, we need to understand the data structures first, because data is what is everything. So what we do, we need to understand the structures in Python. You have something called as built-in data structures. You have something called as user-defined data structures. So our scope for this learning is built-in data structure. So that is what we are going to see in today's session. So what is this data structure? So you can consider the data structure as a storage of data. You have a skeleton. You have a skeleton. In the skeleton, we fill things, right? So you have a base. In the base, you fill something. So means this is this skeleton, this structure is actually having different ways in which it can hold things. So the same thing, data structures, we can call it as organizer of data, storer of data, so that anytime I can use this, I can modify this in future. So that is the idea of data structures. So in Python, we have different data structures, like how I told you. Our scope is limited to built-in data structures for this session. So in the built-in data structures, the first and foremost one is list. Okay, so you have something called as list, you have something called as dictionaries, you have something called as tuples, you have something called as sets. So all these are the built-in types. Now we will start with list. So what I'm going to do in this session is I am going to explain step by step. At the same time, I am going to do hands-on for this. Okay, so what is this list? List is a container. It is going to hold the values of different data types. It can be integer, it can be float, it can be a string, it can be a single character, any type of data, even a list itself can be placed inside a list. Okay, now how it stores is it stores the data in continuous manner in the memory. Okay, now we all have been using a lot of e-commerce sites. In the e-commerce site, see, for example, I would like to buy something relating to my automobile. So how do I do that? So when I enter the web portal, I just first go to the main classification, what I am trying to search, maybe automobiles. So in automobiles, again, I select four-wheeler or two-wheeler or whatever it is. So again, in four-wheelers, I search for accessories. Again, in accessories, I have I chose body covers. Something like this, it keeps on going. All these are list of the data types. Okay, so from this there is a link to this, from this there is a link to this, from this there is a link to this. Like this, I can create many lists for relating this and pulling out the desired information from the data. Okay, now when I say list, the main concept behind this is it is numbered, means indexing is there. So you can understand that the indexing starts from 0. So 0, 1, 2, 3, 4, like that it goes. means the list elements are indexed. The list elements are identified by the index number. So the first element or the first item of the list, the index value is 0. The next one is 1. The next one is 2, like that it goes. Now we need to know what are the things behind this. Now, when I say list, I need to know how to create a list, how to add items to a list, how to access elements to a list, how to modify the existing elements of the list, how to remove something from the list, or how to remove the complete elements of the list, how to add at the end, how to add in between. All this is what we need to learn. So for this, what I am going to do is I am going to open Jupyter Notebook. In that, we are going to do all these things. The same concept, the same way we are going to try out for sets, tuples, dictionaries. So for all these 4, we are going to do like that. So first thing is Python list. How do I create a Python list? All the Python list, the items are enclosed in square brackets, and each item is separated by a comma. Each item is separated by a comma. And second thing is it can hold any kind of a value. Okay, so that is what we are going to create here. Now see this first step. I am just naming this list as list 1. So list 1 equal to just square bracket. If I put, it's going to create an empty list. Now list 2, you can see here 1 comma 2.4 float value is there, comma ABC, a string of characters is there, comma one more list itself I am adding. So all this, any kind of a value, different types of values, this can hold. Okay, so let us try that. What I am going to do now is I am going to open I am just going to open the Jupyter Notebook. In that, we'll be doing this. Okay. So let me open a new Python 3. Okay, see this. List 1 is equal to just empty square brackets. Okay, so if I print this, you can see, shift enter, right? You can see that it's an empty list. Now list 2 is equal to, so I am going to give some value, integer, comma, a float, comma, a string. Okay, let me put it as string itself. So all these things. Now let me just print that list 2, shift enter. You can see that whether it is a list or not, I can easily find out. So how can I easily find out is I need to just use this method or function called as type of list 2. You can see that it shows list. Okay, now coming back here. So that is how you are able to create a list in Python. Now, how do I access the elements of a list? I told you that it uses indexing, right? So you can access the elements of the list using indexing. So indexing starts from 0. Now I am just going to take this, put it there. Okay, print P is small. Now just look at this list. This list 0 index is 5. The value is 5. 1.2 is 1 and string is 2. So now if I print this list 2 of 2, you can see that it has printed string. So this is how it is going to understand what you are looking for to have access to the elements. You just use the indexing. Okay, right. So that is how you are able to have access to an element from the Python list. Now, when I say access to the element in the Python list, I have one more method called as slicing. So what can this slicing do forward and in the reverse order is, see, suppose 10 items are there or 10 elements are there. I want to list out, I want to print out the 4th element to the 7th element. So I can do that easily. So the start element or the start index and the end index I can give here. Okay, so the same way in the reverse order or from one particular number. So all that I am going to show you now. Let me just copy this. Instead of me typing there one by one, I can do like this and I can show you easily. See this. Now what I have done, you can see that list 1 is there. In list 1, I have 1, 3, 5.6, A, Python goodies, 0.4. So all these are there. Now, first one, what I'm trying to do is I would like to slice the list from the second to means the third to 5th element. Okay. Second means 0, 1, 2. So the answer must be, 5.6, A, like that. Suppose after the third element, what if I want to slice? I just put it as 3 and a colon. Now, before the third element, if I want to print, I just add minus to that, -3 colon. Okay, so till the second element means :2. So this is what you are going to see here as results. See this. Okay, so 2 to 5, you can see here 5.6, right, A, Python goodies. So 3, 4, 5. Third element till the 5th element, it has sliced out from the list. Now the next one is after the third element, it has taken. Before the third element, it is showing. And up to the second element, it is showing. Means the 0th element and the first element, it is able to show us. So this is how easily you can slice the list. Okay. Now coming to the next one. How do I modify the elements of the list? How do I delete elements from the list? Okay. So for that, I have an example here, and you have some inbuilt functions also for doing all this. Okay, so that also I will show you because that is going to be very easy for you to understand and put it into use. So for example, see this, I am just copying this. Let me paste it here. Okay. Now, if you look at this, you can see I have a list 3.3, 5.7, Y, Python, 67, 7.9. Now, I want to modify the second element. What is the second element? You can see that 0, 1, comma 2. Okay, so I am modifying the first element, okay, as 1.2. I would like to print that. After that, I would like to remove the second. Second means 0, 1, 2 means why I have to remove. Okay, so for that, what I have used is del space the list of the number. So this is deleting the third element. Let me just run this and show you. See what has happened. In the first result output, you can see this y is there. Okay, and this 5.7 here is replaced with 1.2, means I have modified the value of the first element, 0, 1. That is the first one. Okay, right. So now after that, I have just removed this second element, means why I have removed. So that's why you can see here, it is not shown here. Right? So it is that easy for you all to understand this, how it works. Okay, how do I add to list? I have got two lists. How do I add? Or, what is the logic behind this? If you ask me, just use the plus operator. Using the plus operator, we can do that. See, for example, I have list 1, I have list 2. I just want to add these two lists. So just I'll put list 1 plus list 2. It is going to add list 1 plus list 2. I can copy this to another new list. Maybe list 3 I am going to create, and that list 3 is going to have the values of list 1 and list 2. Okay, so let me just do that for you. Can see here, instead of this list 1 plus list 2, I will put it inside list 3. See this, list 3 equal to list 1 plus list 2. Now let me print this list 3. You can see that. So list 1, which is containing 1, 9.0, t, 4.5, it has picked that. And list 2, it is having a, 5.9. That also it has picked. So both it has combined. So that easy it is. Okay. So this is how easily you can add. Now these are the built-in functions. Let me run this presentation. Okay. These are the built-in functions you can see. Append is a built-in function. So what this is going to do is, I already have a list. I want to add an element at the end of the list. Then I can use this append. Then alternative is insert. So where I want to insert in a specific index or in a specified location, I can insert. Then pop is another built-in function. This pop, what it is going to do is, it is going to delete the last element if you do not mention anything. And you have one more removal function called as remove. So the specified index value, from that it is going to remove. To find out how many elements are there, what is the length, you have a len function. Same way, you can arrange the elements of the list. So how do you arrange the elements of the list is, you can use the sort function. Now in the sort function, if you put reverse equal to true or reverse equal to false, it is going to sort in ascending or descending order. Okay, so index of, I can find a specific index of the element that is passed. Same way, I can use the count function. Number of times a particular value is getting repeated, something like that. Okay, so now all these 8 built-in functions, I am just going to put it in one slide. Okay, you can see that all this I have just made it like this. We will run this in the Jupyter notebook so that you will find. Now before that, please understand the data here, the elements here. You can see that 1, 7, 3, A, X, P, 4.6, 0.2, 3.7, all that is there. So now I am going to add 2.3. So what this append is going to do, it is going to append at the end, right? So after this 3.7, it is going to add 2.3, right? Now, same way, insert. See, the position is 2, 3.9. So 0, 1, 2. So what it has to do, it has to replace that 3 with 0.9. So list 1 pop. So the last element is going to be removed. And I can use the remove function also. So remove of X, it has to remove this X. Pop of 4, particular 4, 0, 1, 2, 3, 4. Okay. And then I'm going to find the length of list. So up to this, let me just copy this, paste it there so that we can save some time. Okay. So everywhere I want to see the results. So what I will do is I will just type list 1 here. Okay. Maybe I will use the print function, print of list 1. Okay. Let me copy this. So after it has appended at the end, it is going to show me the results, how it has got changed. And after it has inserted, it is going to show me what it has done. The same way here also. The same way here also. I am going to do that. I just made a copy of that. So pop of 4. And finally, right? Okay. So here the code is the mistake. Now it will work. Okay. Now you can understand. Initially, it was 3.7, the last element. After I have used append, it has appended 2.3 at the end, right? So after that, I have made a change here. You can see the 3 is replaced as 0.9. You can see that. And after that, I've just mentioned pop. So it has removed this last one, 2.3. Now you can see that. Now, after that, I have removed X. Specifically, I have mentioned X. It has removed that X. You can see that in the list, it is no more available, right? So after that, what else we have done? I have tried to find the length of that, and I have printed that just like that. Okay. So length of list 1, and then finally the list. So the same thing it is going to show you. Okay. So these are the things which we can do with a list. Hope you all have understood the power of list. So same way, when you sort that particular list, you can mention reverse equal to true or false. So that is ascending and descending order. And now you have one more thing in list called as list comprehension. So what is this list comprehension is, I can do some calculations or some condition based on some conditions, all that in a single expression, in a single line. Okay, so you can see here list 1 is having these values 1, -2, 3, -4, 5. Now list 2, see here, this is the syntax. I have mentioned the syntax here. You can see here expression of X for X in list. So what I'm going to do, for each element of this list, I am going to square it. Okay, so each element I'm going to square it. So X double times multiplication, that is asterisk of 2, for what is that condition? For all the X in the list. Okay, so for all the elements of this list. Okay, so what it is going to do, let me show you that also so that we can complete the list part. See this. Initially, the list value was 1, -2, 3, -4, and 5. Now it has got converted it into 1, 4, 9, 16, and 25. Means the list comprehension has happened, and it has just squared all this. Now, let me just change this and show you instead of x. Okay. So x into 2, this time I am just giving x into 2. You can see that. See what has happened. It has just multiplied each element of the list with 2. So 1 has become 2, -2 has become -4, 3 has become 6, and -4 has become 8, and 5 has become 10. This is what has happened here. Okay. So that is all about the list. Now let us proceed with the tuples, the next one. Now, what is the difference between list and tuples? This is a very important thing which we need to understand. Now, in a list, you can have duplicate values. In a list, it is based on indexing, all that we have seen. So tuple is also something like a list, okay? Whereas you call the list are mutable and tuples are immutable. Why? Because each element here, it is identified by ID. Okay, so ID of the value of each element of the tuple. So that is why it is immutable. When we try to modify the value, the ID of the variable changes to that. So that is the difference between the list and tuple. Now, square bracket is for list. The normal brackets is for tuple. Other than that, the same way what operations we try to do there in the list, we can do it here also. Right. So every unique element of the tuple has its own ID, which represents the memory location of that element. The elements with the same value have the same ID. You can see here. I would like to check the first and third elements, whether they have same value or not. Okay. You can see here the first element is 1. And the third element is also 1, means the value is 1. Okay, so I would like to check whether they have the same value or not. Okay, see, the syntax remains the same. Instead of list of that particular square bracket, the element, here you put the tuple name. That's all, right? So the same way you can add two tuples, like how you added list, all that is fine. All that is not going to change. Okay. So let me together show you that example in the Jupyter notebook. Now you have another concept called as packing and unpacking in tuple. What is that is, see, without a bracket, I can just add values to a tuple. See, for example, you can see here, tup is equal to 1, 2, 3, something like that. I have added the values. This is called as packing. Now, I have to unpack that. Okay. So the other way, if I put it, see, for example, A, comma, B, comma, C equal to tup. Now, what will happen when I print the A value? What will happen when I print the B value and C value? Okay, so this, let me show you so that you will understand how the packing and unpacking happens here. Say this 1, 2, 3 is what is stored to A, comma, B, comma, C. Means each one is having a unique identity. The 0th element, or you call the first element, the second one, third one, each one is assigned to this, A comma B comma C. So that is how you can pack and unpack a tuple. Right. Now the next thing is set. What is the difference between again a tuple and a set? We have to understand here. So sets are also a collection of elements. These will not have duplicate values, and the elements are not ordered. How you have added the elements, the same way it is going to be. So what is the inference? You cannot use indexing here. Okay, always by default, the set values, it gets arranged in ascending order. So how do you identify it as a set? Is very simple. Curling braces enclosed between curling braces and elements separated by comma by like list and tuples. So square bracket list, normal braces is tuple, and curling braces is sets. Okay, right. Now in sets also you have all these options: add, pop, clear, link, remove, discard. All this you have. You can see here I have given an example. Since I want to focus something for dictionary, I would just show in this screen itself. I will explain you. So set 1 is this, set 2 is this. Now set 1 dot add of 5. So it is going to add 5. Okay, maybe I will just copy this and show you how it works. It's not going to take even a minute, but you will understand what it has done. See this first one, I have added 5. Okay, set 1 dot 5. Okay, and I am just printing the set 1, and then length of the set 1. So length of the set 1 previously 1, 2, 3, 4, 5. I have added 1, so it has become 6. You can see here the answer as 6 that I have printed. Okay, then after that pop means the last element is removed. Okay, then set 2 is this, it has removed that, and after that I am removing A. Okay, set 1 I am removing A. You can see here A is already there, so that is removed. Then I have printed that, so it has done that. Okay, now the same way you know, I can do it for the set 2 also. So these are the results you will be able to see. Okay, see already I have removed from there, so that is why one error you are able to see. Okay, so that we have done already. Right. Now there are something which is not available in a list and a tuple is available as operations in sets. What is that? Operations in sets is you can do some mathematics. You have union, you have intersection, you have difference, symmetric difference. Okay, so union is it is going to combine values from both the sets. Okay, and I told you that it will not allow duplicate, right? So only once it is going to pick. Intersection, which is commonly available from both. Difference, which are not available in the first and second one. Symmetry difference, okay, not common to the sets. For this, I have an example for you so that you can understand this example. See this, set 1 is having some values, set 2 is having some values. I need to just use this method or function union, intersection, difference, symmetric difference. Okay, I'm just printing the results. You can see that. So union, it has just combined. Okay. And you can see that it will not allow duplicates. Intersection, only 1 and A are there. Difference T to 7.5 are there. Symmetric difference to 6.7, 7.5, all these are there. So these are the mathematical operations that you will be able to do in sets. The last type of inbuilt data is called as dictionaries. Okay, so I was telling you an example of the automobiles, right? Automobiles, four-wheeler, two-wheeler, three-wheeler. In that, again, four-wheeler, when I select, I will be able to select accessories. In accessories, again, you have a lot of. So all these, each one is identified by a key, right? So that is where we will be able to use the dictionaries in Python. So I have a key, I have a value. So it is a pair. Okay, so it's a data structure that stores key value pairs. So that's what is called as dictionary. So this is something like a real life dictionary, okay, where you have the word and the meaning for that in the dictionary. The same way here, you have the key and the value for that. Okay, so keys should be unique, cannot be changed. Dictionary uses curling braces. Okay, so separated by comma means key value and key and the value, and then this is separated by a comma. So how do you access the dictionary values is using the keys. Using the keys, you can access the values of the dictionary. Okay, so the same way how you access the elements of a list or a tuple, the same way you can use the square brackets to access it. So here also, like other data structure types, you have something called as get. Pop is common, pop item is there. Okay, and then clear all the elements of the dictionary. See whether list or dictionary or tuple, when you use this clear, it is going to clear the elements of that list or dictionary. Okay, keys is going to show you all the keys in the dictionary. Values, it is going to show only the values in the dictionary because it is a combination, right? So it is going to have key and value. I want to see only the keys means I go with the key method. I want to see only the values means I go with the value method. Okay, and if I want to see in pairs means I go with the item method. So keys, values, items. So this is how it's going to be. So this is the last example for us for this session. I will just copy this and I can explain you it here so that it is easy for you to understand. See this. Now for easy understanding, I have put it like this. Key is 1, value is A. Key is 2, value is 3. Key is 3, value is I. Means A, E, I, O, U, right? The vowels, I have put it like this. Okay, now see this, what it is going to do. All that what I have shown you there, I have added it here. Get, I have added. Keys, I have added. Values, I have added. Items, I have added. After that, I am popping out. Okay, so, and finally, I am clearing the contents of the dictionary. Okay, let me run this and show you. Okay, so O is the fourth element. You can see that. So that's why O is the result here. And the keys alone, I want to see 1, 2, 3, 4, 5 are the keys. Values alone, I want to see. You can see A, E, I, O, U are the values. Now items means in pairs. So key and the value, you can see 1, A, 2, E, 3, I, 4, O, 5, U, right? So then after that, I am assigning the pop of 2 to variable 1. So you can see that E is the second one. So the key, what I have given there is 2. And the value for that is 3 that I have transferred to variable 1, where 1. Okay, same way I have given pop item. So pop item, it is going to be the last one, the pop one. So that is what it has done. So pop item, the last one is 5, comma u. Key is 5 and value is u. It has removed. And finally, I have asked it to clear all the elements of the dictionary. So it has cleared all the elements of the dictionary. And finally, when I have printed it as dict1, you can see that it shows dict1. Okay. So that is all for this session. A quick recall of what I have taught you all in this session. So we have seen about the different inbuilt data structures in Python. We have seen about lists, how to create a list, how to access the elements of the list, how do you add at a particular position, how do you add at the end of the list, how do you remove at the end, all that we have seen how to modify the list. The same way, sets, tuples, and dictionaries. And I have taught you what is the difference, what is the purpose, when do we use dictionaries, when do we use list or sets or tuples, and I have shown you all the differences in these inbuilt data structures. So there are some user-defined data structures also, which is not the scope for this basic level of Python learning. Maybe when we move on to the advanced level of Python learning, that time you will be able to understand all that. So that is all from my side for today's session. If you have got any questions, you can ask me. Okay. Let me stop the sharing.
Yogesh, one of the questions came from YouTube.
Okay.
Updated in the chat section. Why NumPy array is better than Python list?
Okay. Okay. See, because it is of a homogeneous type, means see, suppose now what we have seen in this example is just 5-6 items in the list. Okay, but if it is the same example, you can take the automobile accessories example. You have some 200 plus items, or hundreds of items you have. In that, when it is stored one after the other, how it is arranged, the memory occupation of that is going to be much higher. So that is why this NumPy array, it is better comparing this normal list. Okay, because it can hold a lot of elements, as well as it can release it from the memory faster. So the access point when you query upon it is much faster. So that is the difference. Okay, I can see one more question. What is dictionary in Python? The last topic in our session. Now we have seen that only. Anyway, let me explain you. See, the dictionary in Python is something like a normal dictionary that we use. Means in a dictionary, you find a word, and for the word you have the meaning. The same way here, you maintain it as a value and a key. So for each value, there is going to be a key. You identify the value with the key. That is the difference between a normal list and a dictionary. Okay. So depending upon our requirement in our project, we go for a dictionary or a list. So if I need to say that I need to have a key and a value for that, like this, I have a lot of pairs, then I will go for creating it as a dictionary. If only the elements are there, 100, 200 elements are there, then I'll go for a list. And in that also, I do not have any duplicates or something like that. Maybe I would like to go for sets or tuples. Any other questions? Okay, I can see one more question there. Linked list. What is a linked list in Python? See, lot of links are there, means a lot of lists are there, or some data elements are there, which are connected by means of, by means of a list. Okay, so that is actually, we call it as a linked list. It is called as a linear data structure. So unlike arrays, the elements, it is not stored, in a contiguous location. Elements are linked using pointers. So when we learn more about this in programming in Python, so we'll be learning all these things. So we call it as, linked list elements. These linked list elements are linked through pointers. Okay, so each, includes series of nodes, NODs, nodes. So these nodes stores the data and the address of the next node. This concept is same in C++, Java, and all that. Okay, so in a line or a linear data of similar type means, then I can go for the linked list. Okay. Currently, I am using Excel for my daily activities. When I should switch to Python? I am interested in data science field. Okay. See, I am also a person who has been using Excel for quite a long time. I tell you what really makes a difference. See, many companies, wherever I have delivered training programs also, I have seen many companies, they are still using Excel for all the analysis part. Now, if you want to get more insights of your data, you mean to say that you have an Excel workbook where you have voluminous data, you have some 15 columns of and thousands of rows of data. You want to get better insights of your data analysis, and then you can think about switching to Python. Okay. So because you say that I'm interested in data science field, I can tell you in Excel itself, you can do a lot of analysis, you can do a lot of analytics, you can find out the insights, but more insights or better insights of your data when you do a data transformation, and then you find the insights of your data. All that needs, a programming language like Python, which makes it very easy. Okay, so because of its exhaustive libraries and all that, that amount of time that you're going to spend with Excel, it is going to drastically come down when you switch to Python. So data science field, if you are interested in switching, it's going to be easy for you now, because you say that you've been using Excel for all your daily activities. So now itself you have you would have have the experience of creating a lot of different kinds of reports, different kinds of analysis and all that. When you take it to Python, you know that it's something like a English like language. We use all English words as keywords for writing the code. So in that case, it's going to be very easy for you. See, what you have been doing in Excel, you will be able to do it better analysis and all that. So that is the reason why you can switch to data science field. And apart from this, if you ask me, you can think about a complete course instead of just thinking about Python. You need to know about the various other aspects of data science. So when you learn, put together all that as a complete program, maybe a certification program, then it's going to be very helpful for you if you are interested in switching your career to data science field. Hope I'm clear with my answer. Okay, there is one more question. This I have actually explained in the presentation, but again, I can go with it. Why we use tuples when we have the list data type? The simple difference. This is mutable and list is mutable and tuples are immutable. That is the difference. List, it is indexed and you identify all the elements with the index values. There it is tuples, it is not based on the indexing concept at all. So that is why each element is identified by a value. So that is the reason. See, again, here you need to based out on the requirements. Okay, suppose my data is something like this. See, it is having a lot of repetitive values. Maybe the duplicate values are there. I want to maintain it, means I'll go for the list data type. Okay, so where I want to identify each one as a unique value, all that, then I'll go for the tuples. So that's what I said. That's why in today's session, we have seen the 4 different types. Depending upon the requirement, we are going to use any one of these 4 types. Okay. So hope there are no more questions. Thank you all. See you again in one more session in the series of webinars for Python learning. Thank you.
I think, Yogesh, I think we have a session on Thursday. I think the people watching us on online, so make sure that you join on Thursday. We have a session on series 4 on Python.
Wednesday, I think. 12,
correct. So Wednesday.
14, Wednesday. Yeah, Wednesday. Yes.
So Wednesday we have a session on 3 p.m. You will notify from DataMites team. So thank you everyone for joining today. Wish you a good day. Bye.
Thank you all.